So to find the domain of these, we look for the roots of the denominator. So for number 1, what are the factors of the denominator? X plus 4 and x minus 3. So x is not allowed to be negative 4 and positive 3. So on 1 through 8, all you're going to find are the discontinuities. Where does the graph not have a domain? So the domain, well, technically the domain is all real numbers, but x is not allowed to be negative 4 and 3. We're doing, so 321 is 1 through 16 all. Now, in the next section, you get to figure out why does negative 4 not work and why does 3 not work. What do they look like on the graph? So there are two options. So anytime you have a rational function is a fraction where there's a polynomial on top and a polynomial on bottom. And rational functions look like this with vertical asymptotes. There's another vertical asymptote. And they can also have holes. So we need to figure out, how do you tell the difference between a hole and a vertical asymptote? And it's actually really easy. You look at the original equation, and when you factor it, do any of the factors cancel? So the problem is actually x plus 4 over x plus 4 times x minus 3. So the x plus 4's cancel, and we end up with 1 over x minus 3. And the way I remember which is a hole and which is a vertical asymptote is, if I had 10/16, that is equivalent to 5/8. Those are exactly the same. Okay? So this graph and this graph are identical with one difference. And that difference is the simplified version plugged a hole. So when I canceled these here, I plugged a hole. You can't get rid of a vertical asymptote. So this is a vertical asymptote. So we would call 3 a VA. If it cancels, it's a hole. And the way I remember it is, the graphs look the same. If you were to graph the original, x plus 4 over x squared plus x minus 12, and you were to graph 1 over x minus 3, you would not see any difference on your calculator. Your calculator does not display the holes. So the holes are the ones that are plugged when you simplify. Okay? So number 9, does that have any holes? It has no holes. It does have a vertical asymptote at -2. Okay? And then it wants to know about horizontal asymptotes. And horizontal asymptotes are really easy. Okay? The horizontal asymptotes are created by dividing the leading term on top by the leading term on bottom. So if I have x to the 4th plus, a lot of stuff that doesn't really matter, and 2x to the 5th, none of that stuff after the leading term will affect the horizontal asymptotes. All you have to do is divide these. What do you get when you divide those? 1 over 2x. Okay? Where is the horizontal asymptote for 1 over x or 1 over 2x? It's the same. If you were to graph 1 over x, it would look like this. And 1 over 2x is just a little bit further out, but it has the same horizontal asymptote, which is at 0. Okay? Now, if I did 1 over x squared or x to the third or x to the fourth, they will all have a horizontal asymptote at 0, an HA at 0. Okay? If you have 5x to the third over, let's do 15x to the third over 5x to the third, and once again, none of this stuff is going to matter when dealing with the horizontal asymptotes. It will affect the verticals. What do you get when you divide those? 3. So your HA is 3. So you would have this graph would have an HA up here at 3 or something like that. It might even be, it could look like this, but it would have an HA at 3. Okay? But if we had 6x to the third over 2x squared. So you divide those two and you get 3x. This is called a slant asymptote, where we graph 3x, and the graph is going to approach that slant. So it could look like, oh, it might look like this. So it's getting closer to that slant there, and it's getting closer to that slant there. And notice, it did pass through the asymptote. That can happen. It's actually really common. Asymptote means as you approach infinity, they get closer together. But it is really common to cross over an asymptote. So this does not have an HA, it has an SA, a slant asymptote. And you can even get more complicated than that. If I had 18x to the fourth over 2x squared, and again, these are going to have more on the ends. I divide those and I get 9x squared. This is a quadratic asymptote. So the asymptote would look like this. So your graph might be yeah. So it's going to get closer and closer to that parabola. Wow, that's new. And if you change this to x to the fifth, then you would have a cubic asymptote. And you probably aren't going to see those. Today, I think they're just going to stick with horizontal asymptotes, but slant asymptotes are really common. You just have to divide the first term on top and the first term on bottom. So if I had this, where are the discontinuities, the vertical asymptotes, and the slant asymptotes? So we know x is not allowed to be 0, 3, or 5. Everybody get that? Okay. Do I have any vertical asymptotes? This one will be a vertical, and this one will be a vertical because those two are holes. So I have a VA at 0 and at 3. I have a hole at 5. Do I have any horizontal asymptotes? Well, what is the leading term going to be on top? X squared. So if I were to multiply all that together, I'd get x squared on the top. What's the leading coefficient going to be down here? X to the third. And I divide that and I get 1 over x, which has a horizontal at 0. So the HA is at 0. And that's actually a y value, right? You need to remember that HAs are y values. Okay? So look at let's do Let's do number 13. Well, actually, you have answers to 13. Let's do 14. Okay. Um, let's factor it to figure out where the roots, what the discontinuities in the bottom are. So I recommend using the box. 6x squared and 1. What do I do now? Multiply those together. You get 6x squared. Are there factors of 6 that add to be 3? Our options are 1 and 6 and 2 and 3. No. So what does that tell us about the top? It's either imaginary or irrational. So are we going to have any holes? Probably not, unless the bottom has the same imaginary or irrational roots. All right, so let's try the same thing with the bottom. 3x squared, negative 2. Multiply those together, and we get negative 6x squared. Are there factors of negative 6 that add to be negative 5? So negative, well, they got to be different signs. Negative 6x and positive x. What does the top row share? 3x. So this would be x, and this would be minus 2, and this would be plus 1. So the domain would be all real numbers, but x is not allowed to be 2 or negative 1/3. Everybody get that? So we would subtract 1 and divide by 3. Now, are those holes or are they vertical asymptotes? They're both vertical asymptotes because the top didn't factor. So both of those are VAs. And if I divide the leading terms, what do I get from that division? 2. And that would be a horizontal asymptote. So there's an HA at y equals 2. Does that make sense? Okay. Look back at number 13. Is it going to have a horizontal asymptote? It's going to have some sort of asymptote, but it won't be horizontal. So you divide that and you get x to the third. It's a cubic asymptote. But it only wants you to list the HAs. So that one, I don't think they want you to list anything. Okay? All right. That's everything you need to know. Good luck.